NFPA 72, the National Fire Alarm and Signaling Code, does not specify a maximum number of wires that can be connected to a strobe light. However, this does not mean that there are no limitations or considerations when wiring a strobe light. While NFPA 72 focuses on the performance and functionality of fire alarm systems, including strobe lights, other electrical codes and standards such as the National Electrical Code, often abbreviated as NEC, and manufacturers' specifications, provide guidance on safe and proper wiring practices. When installing or modifying a strobe light wiring system, it is crucial to consult the manufacturer's documentation for specific instructions and limitations. Manufacturers typically provide detailed information on the appropriate wire gauge termination methods and maximum load capacity for their devices. Ignoring these specifications can lead to equipment malfunction, fire hazards, or other safety issues. Firstly, you must consider the current carrying capacity of the wires used to connect the strobe light. The NEC provides tables and guidelines for determining the appropriate wire gauge based on the amperage of the circuit and the ambient temperature. Using undersized wires can cause overheating, insulation damage, and potentially a fire. Secondly, you should be mindful of the voltage drop in the wiring system. Voltage drop occurs when the voltage at the end of a long wire run is lower than the voltage at the source. Excessive voltage drop can cause the strobe light to function improperly or not at all. The NEC provides formulas and guidelines for calculating voltage drop and selecting the appropriate wire size to minimize it. Thirdly, you need to ensure that all wiring connections are made properly and securely. Loose or corroded connections can create resistance, which can lead to overheating and equipment failure. Use appropriate connectors and termination methods for the type of wire being used, and ensure that all connections are tightened to the manufacturer's specifications. Fourthly, it is essential to follow the grounding requirements outlined in the NEC. Proper grounding helps to protect against electrical shock hazards and to minimize electromagnetic interference. Connect the strobe light to a properly grounded circuit and ensure that all grounding connections are secure. Fifthly, you need to adhere to the wiring methods specified in the NEC. This includes using approved wiring methods such as conduit, cable trays, or raceways to protect the wires from physical damage and environmental factors. The NEC also specifies the minimum clearances and spacing requirements for wiring. Sixthly, you should consider the environmental conditions in which the strobe light will be operating. If the strobe light is located in a damp or corrosive environment, use appropriate wiring and connectors that are designed to withstand these conditions. Seventhly, you need to ensure that the wiring system is properly labeled and identified. This helps to prevent confusion and errors during maintenance and troubleshooting. Label all wires and connections with their corresponding circuit numbers or function descriptions. Eighthly, you should perform regular inspections and maintenance on the wiring system to identify and correct any potential problems. This includes checking for loose connections, damaged insulation, and corrosion. Ninthly, it is important to consult with a qualified electrician or fire alarm technician if you have any questions or concerns about wiring a strobe light. These professionals have the knowledge and experience to ensure that the wiring system is installed and maintained properly. Tenthly, be sure to verify that the power supply is compatible with the strobe light's voltage and amperage requirements. Mismatched power can damage the equipment and create a safety hazard. Furthermore, consider the placement of the strobe light. NFPA 72 provides guidelines for the spacing and location of notification appliances, including strobe lights, to ensure adequate coverage and audibility. Ensure that the strobe light is positioned so that it is clearly visible to occupants in the area and that its flash pattern is not obstructed. When working with electrical wiring, always follow safety precautions to prevent electrical shock and other hazards. Turn off the power to the circuit before working on any wiring, and use appropriate personal protective equipment such as gloves and safety glasses. Never work on live electrical circuits unless you are properly trained and equipped to do so. Always verify that the circuit is de-energized before beginning any work. In summary, while NFPA 72 does not explicitly state a maximum number of wires for a strobe light, A variety of electrical codes, manufacturer's specifications, and safety considerations must be taken into account during the wiring process. Adhering to these guidelines will ensure a safe, functional, and code-compliant installation. Remember that local codes and regulations may also apply, so it is always best to consult with local authorities or a qualified professional to ensure compliance. Finally, document all wiring modifications and additions to the fire alarm system. This documentation should include wiring diagrams, equipment specifications, and test results. Keeping accurate records will help to ensure the system's long-term reliability and maintainability. The specific strobe light model also dictates the number of wires necessary for its functionality. A simple strobe light might only require 2 wires, one for power and one for neutral, while a more sophisticated model with advanced features like remote control or synchronization with other devices may require additional wires for communication or control signals. Therefore, the complexity of the strobe light's design directly influences the number of conductors needed. Also consider the method of connection. Some strobe lights may use screw terminals, while others use quick connect connectors or even require splicing. Each method has its own limitations on the number of wires that can be reliably and safely connected. Screw terminals, for example, have a limited space and torque capacity. Over-tightening or trying to cram too many wires under a single screw can lead to loose connections and potential fire hazards. Quick connect connectors, while convenient, also have a finite number of ports and wire gauge limitations. Splicing, if done correctly, can accommodate multiple wires, but it requires careful installation and protection to prevent shorts and ground faults. The type of wire used also plays a role. Solid core wire is generally more difficult to work with when connecting multiple wires to a single terminal compared to stranded wire, which offers more flexibility. However, solid core wire might be preferred in some installations due to its durability and resistance to corrosion. Furthermore, the gauge or thickness of the wire affects the number of wires that can be safely connected. Thicker wires require more space and are more difficult to bend and manipulate, limiting the number that can be comfortably accommodated in a terminal. The environment in which the strobe light is installed also impacts wiring decisions. In damp or corrosive environments, special precautions must be taken to protect the wires and connections from moisture and corrosion. This might involve using waterproof connectors, corrosion-resistant wire, and sealing compounds to prevent water from entering the wiring system. These protective measures can also affect the overall space and number of wires that can be practically connected. Also, keep in mind the concept of derriting. Derriting refers to reducing the allowable current carrying capacity of a wire when it is bundled with other wires in a confined space. The NEC provides tables that specify derriting factors based on the number of current carrying conductors and raceway or cable. If multiple wires are bundled together to connect to a strobe light, it might be necessary to increase the wire gauge to compensate for the derriting effect, which further limits the number of wires that can be practically connected. And don't forget about future expansion or modifications. It's always a good idea to leave some spare capacity in the wiring system to accommodate future additions or changes. This might involve running extra wires or using a larger junction box than is currently needed. Planning for future needs can save time and money in the long run and prevent the need for costly rewiring later on. Ultimately, the question is not necessarily about a maximum number of wires that NFPA 72 restricts, but rather about ensuring that all wiring practices adhere to accepted electrical standards, manufacturers' instructions, and relevant safety codes. A safe and reliable installation is the result of careful planning, proper material selection, and adherence to best practices. So always prioritize safety and consult with qualified professionals when in doubt.